If you land at Schiphol Airport today, you're touching down on the bottom of a former lake, 13 feet beneath the nearby ocean. By the laws of physics, this entire country should be a seabed. If the pumps stopped running today, the water would return and reclaim the land within days. Yet, in spite of this sinking geography, nearly 18 million people live and thrive here. They've built an industrial economy on territory that nature intended to be underwater. This land began as a spongy delta. Over thousands of years, rivers like the Rhine dumped silt and peat into the North Sea, creating a saturated marshland. The first inhabitants survived by manual labor, hauling baskets of soil to build artificial hills called terps. These mounds provided the only dry ground for their homes and livestock during high tides. The very existence of this nation is a manufactured achievement, the result of a 1,000-year engineering conflict against the rising tide. About a millennium ago, the strategy changed from passive survival to active expansion. The Dutch began building dikes to encircle and drain entire sections of the marsh. Because a single weak point in a dike would drown everyone behind it, the threat created a unique local government. These water boards are among the oldest democratic institutions, formed so neighbors could collectively tax and maintain shared defenses. These iconic windmills functioned as industrial water pumps. They were built to mechanically lift water out of the marshes and into higher canals. This created a polder, land where the water level is kept artificially low by constant pumping. But draining the water causes the peat swale to dry and sink. The better the pumps work, the lower the land drops, forcing an endless loop just to maintain dry ground. The Netherlands exists within a cycle of constant effort. Like a bicycle, the nation remains stable only as long as its people keep the pedals moving. That stability was shattered on February 1, 1953. A massive North Sea storm surge collided with high spring tides, pushing the ocean level several meters above its normal range. The storm shattered the country's defenses in dozens of places, flooding sleeping villages and killing more than 1,800 people. Folklore suggests a child's finger could stop a leak, but the physics of a dike breach are violent. Under the weight of a storm surge, even a small leak scours away the embankment's core, collapsing the wall in minutes. Real heroism that night took a different form. A local skipper intentionally steered his heavy grain barge into a massive gap in a primary dike. The hull jammed in the breach, blocking the torrent long enough for the town to reinforce the wall with sandbags. The disaster proved that local defenses could no longer protect the modern nation. It triggered the Delta Plan, a national engineering mobilization to secure the entire coastline. This project, known as the Delta Works, sealed off the country's vulnerable southern estuaries with a network of massive dams and storm barriers. The Oosterschelde barrier uses movable steel shields. These stay open during normal weather to preserve the local oyster and mussel habitats, but they drop down to seal the estuary when a storm is predicted. To protect Rotterdam, engineers built the Maaslandkering. It features 2 automated floating gates, each as large as the Eiffel Tower, that swing together to block the river only during extreme surges. These structures provide a level of safety found nowhere else on Earth. While most countries build dikes for a 1-in-100-year storm, the Dutch primary defenses are designed to withstand a 1-in-10,000-year event. On the north coast, they manufactured an entire province. By draining a massive bay, they raised Flevoland, the largest artificial island ever built. Because this land was once a seabed, modern farmers often strike the oak timbers of 17th-century shipwrecks with their plows while working their fields. Today, farmers ride their bicycles past fields of tulips planted on ground that was a saltwater habitat just a century ago. Through this massive industrial coordination, the Dutch forced the North Sea into a managed, mechanical state. But climate change is making higher walls an obsolete strategy. Building taller dikes is an unwinnable race against a rapidly rising global ocean. This led to a strategy called Room for the River. The government is now buying back fertile land and intentionally flooding it to give rivers space to expand during surges. By creating these strategic spillways, the Dutch can absorb massive volumes of water in natural reservoirs, completely preventing floodwaters from reaching major cities. Architecture is also changing. Built on floating foundations, these houses slide up their steel pilings as the water rises, remaining perfectly dry. To protect the beaches, they built the sand motor, an artificial peninsula using natural ocean currents to distribute sand along the coast without constant dredging. Resilience no longer means fighting a war against the water. It means engineering a way to intelligently live within it. Coastal cities around the world now face the same rising threats. Modern hurricanes and sea level rise are turning urban streets into permanent flood zones. When New York or New Orleans needs to design modern flood protections, the first call they make is to Dutch engineers. The Netherlands remains a society in motion. It survives because its people continue to pedal, maintaining a delicate balance through constant work and engineering. Their story proves that through scientific reason and communal compromise, humanity can build a thriving home, even in the most hostile environments on Earth.